Hello everyone. Today I'll be teaching you about the introduction on statistics subjects, which is descriptive and inferential statistics. Before we dive in, let's see what's the difference between descriptive and inferential statistics. On the left, we have descriptive statistics, and the point here is to summarize and organize data to present it in a clear way. We see here is the central tendency and dispersion. There's a mean, median, standard deviation, etc. All of this we have learned back in high school, as well as take information from the graph like histogram, for example. Inferential statistics, on the other hand, is to make prediction, conclusion, and hypothesis tests about the population from a sample. There's a probability distribution, hypothesis testing, and chi-square, etc. Now, this one is where we learn in university. If you take statistics, and we will dive more into these subtopics in the future. But for now, we focus on the descriptive statistics. Just to jog your memories before we conquer the harder content, since a lot of the basics like the mean, variance, and standard deviation, we will see and use them frequently in inferential statistics. So without further ado, let's move on. We see the list of content for these topics. We start with terms and definitions. So there's population and sample. Population refer to an entire group of people or object under study, while the sample is a subset of population taken under study. So for example, let's say there's like 1,000 students at a university. This is what we call populations. And now we want a sample from our analysis or observation. It doesn't matter what for. It can be height, weight, or CGPA. In this case, we take or observe 20 students from the population, which we call it a sample. Next is random variable. It's a probability of values or outcome that happens by chance, like a coin flip and dice. There's a measurable and non-measurable random variables. We see that for measurable, it basically means a data that can be countable, like your height and weight. It's called quantitative random variables, which can be either discrete or continuous. But what's the difference between these two? So we look at some of the examples here. Easy to understand, just remember that discrete can only be counted with a whole number, while the continuous, like temperature, can be more precise. Like, let's say its whole number is 120 degrees Celsius, but it can be like 120.35 degrees Celsius. But in discrete, you can't say the number of students like 21.7. Like, it doesn't make sense. It can only be 21. Now, for the non-measurable, it's a qualitative random variables. Compared to quantitative, it has nothing to do with numbers and more about the labeling or categories of set data like races and genders. So its purpose here is to understand, predict, and find patterns. For example, if you're in a marketing department and see that there's a large incline on your newest product, and the demographic that buy that said product on its peak are women in her early 20s. And the next subtopic is a central tendency. We use mean, median, and mode to obtain the central data set. Firstly, what is mean? We see that mean is to calculate the average by sum all data divided by the number of data size. There are two formulas, one for population and samples. It's basically the same formula, but which one you will be using will be depending on the information that you want to observe. So let's take an example. There's like a 4 data set. This is the data that we take from a sample. So the number of sample we observe is our sample size, meaning that we will be using the sample mean formula to find our mean. So we total the all up divided by the number of sample, which is 4, and then we get the answers. Now for median, to calculate median, we arrange the set data in ascending order and take the median value. There will be a situation whether the data size is odd or even. In case of odd, it is very straightforward. Take the middle, the answer is 23. In case of even number, so we take both of these numbers, 3 plus 30 divided by 2. That it will be our median. Next is how to calculate the mode. Is by taking the number with the highest frequency. In this case, on the example, the highest frequency is 34 since it have 3 the same numbers. So the answer for the mode will be 34. And finally, the last subtopic is dispersion. It refers to the number of values that shows the variability of a set data. The data are widely scattered when the dispersion is large. The dispersion are range, variable, and standard deviation. We start with range. It's very simple. Just calculate the difference between the largest data and the smallest. So here we have 56 minus 23. So 56 minus 23, it will be equal to 33. That is our range. Now we dive into variance, and this can get a bit complicated. So variance is a measurement of how spread each values in a set of data from the average or mean. So the lower the variance, the closer it is the data will be scattered around the mean. There are two formulas of variance, the population and sample variance. As long as you have all the information like the mean, this is our mean, and or memorize or understand the formula, it should be no problem to solve it. Lastly will be the standard deviation. It's basically just square root of the variance we get previously. If you know the variance formula, then you should know the standard deviation as well. After knowing all the basics, as promised, we put those knowledge to a test example. So a law firm investigates a series of suspicious car accidents potentially linked to illegal vehicle modifications. As part of the investigation, an analyst conduct control crash tests to determine the impact speed required to cause bumper damage. The following data represent the impact speeds of 10 vehicle tests. This is the data. Analyze the data by calculating the mean, median, mode, range, variance, and standard deviation. We can ignore the extra for now and focus on the question. So before answering the questions, we need to extract the information provided. So it gives us a total of 10 datas. And since there's no mentions of all cars, of specific model, year, or anything that can indicate that this is from a population, we can assume that this is a sample size. Remember that this is important to distinguish the sample with population, or you will be getting the wrong answers for variance and standard deviations. Since this is a sample, then n then n, which represents sample size, will be equals to 10. Now that we have extract all the information, we can start answering the questions. We start with mean. The formula of sample mean is this, and we have all the information needed, so we just need to insert the total of data divided by n is 92 plus 100 plus the dot divided by our sample size, which is 10, and then we will get our answers for the mean, which is 100. Next is the median. So we start with arranging the numbers in the ascending order, which is 90, 92, 100, 4, 1. So our median will be, since the size data is 10, it's an even number. So we take both the central numbers, which is 99 and 10. So this is plus, 100, which is plus 100. So divided by 2. And then we will get our median, which is 99.5. So now for the mode will be 104, since there are two of them. Mode is 104. And then for the range 111, 101, the highest number. So for the range, for highest number 111 minus lowest number, which is 90. So equals to 21. So we already get the answers. With variance, however, we may take a bit longer to solve it because there's like a 10 sample size. So we start with the formula like we learned, which is S square. This is the formula for variance. Intend here as of our data size. So we start with the formula, and then we have n equals to 10, and then the mean we have solved before, which is equals to 100. And right here is the total of each individual data that we will calculate it by one. So I make a table. Just to make it easier to see and understand, okay? Our data, so we start with 92. So 92 minus mean 100, which equals to negative 8. So negative 8, so we square it, which we will be getting 64. So the first data is 64. Rinse and repeat for all 10 datas. So here 100 minus 100 is 0. So it will be 0. And then for all 10 of them, so I fill in the answers. So 1 divided 10 minus 1. So here 64 plus 2 plus 4 plus 25 plus 16 plus 9 plus 1 plus 1 plus 10. So the final answer will be 46.2. So this is our variance. Finally, for the standard deviation, so we just the square root the answer we get from the variance, which is final answer will be 6.7987. And that's all. We have answered all the questions. So looking back at the exercise, I put in the extra, which is to find mean and standard deviation using calculator. So why we need to use calculator? Well, because in university level, sometimes the question give us 30 data samples, and the more samples you have, you are prone to make human mistakes. So this is like a safety measure, so you can check if your answer is correct or not. So this is how we use the calculator. I'm using what I had, which is 570 ES model. It may be different for you if you're using Casio or 570EX, which you can find easily the tutorial on YouTube. I will start now. So firstly, shift clear, and number 3 to clear all. Next step will be shift mode, and then we press down, press down, and then press number 4 to on the frequency. Next step will be we press mode, and then press number 3, then press 1. This is where we insert our data. So okay, this all 10 of our data. Then we press AC, press shift, press 1, and then press 4. Okay, this here. Okay, so make sure you choose the right symbol here. Number 2 here means it's a mean. The number 3 is standard deviation for population, and number 4 is the sample standard deviation. So we start with mean, to our mean. Here we have it. It's 100, the same as the manual one. And then we press AC to find our sample standard deviation. Do the same thing. 4. And then press 4 equals to, we've got the 6.7986. The same answers. And that's all for this topics. This is all very basic since this is just the introduction. I want to clarify, I won't be covering the topic after the introductions like probability and random variables, since all those topics has been covered in high schools. Instead, I will jump straight to probability distributions like binomials and Poisson. Anyways, thanks for watching.